Hello everyone, welcome to Genius Tutorials. So today in this session we are going to continue with our Pgdba 2020 practice session series, and in this session we are going to take few questions on matrix and determinant and continuity and differentiability. Okay, these two are again important topics from exam point of view, and let's start with the session. But before going to start the session, do subscribe to our YouTube channel, and those who want to join our crash course can go through details in description below. Okay, so let's start with this first question. In this question it is given that if A is equal to -4, -1, 3 and 1, this matrix is given, we have to find the determinant value of this. Okay, so first of all let us calculate A square. A square will be -4, -1, 3, 1 into -4, -1, 3, 1. If you multiply these two matrices, you will get 13. This will be 3. This is -9, and this is -2. Okay. One more thing, if you calculate determinant of A here, determinant of A is 1. Okay. And we know the determinant of AB. This is equal to determinant of A into determinant of B. Now determinant of A square, we need to calculate determinant of A square. It will be determinant of A into A. Na? That means determinant of A into determinant of A. But we know the determinant of A is 1. So it will be 1. So that means in this way we can say determinant of A cube, determinant of A to the power 4. All these determinant will be 1 only, because determinant of A is 1 here. Now we need to find determinant of this matrix. That means we need to find this determinant. We can say it will be A. If I take A to the power 2014 common out of it, it will be A square minus 2A minus I. And if I calculate determinant value of this, it will be determinant of A to the power 2014 into determinant of A square minus 2A minus I. A square minus 2A minus I, you can calculate it because A square is 13, 3 minus 9, 2. If you calculate it, you will get this matrix 25 minus 15 and minus 5. Now its determinant will be minus 25 and determinant of this is 1. So it will be 1 into minus 25. So minus 25 is correct answer to this question. Option D is your correct answer. Okay. The property we have used here is this determinant is equal to determinant A to the power 2014. This is property of determinant. Okay. So I hope this question is clear. Let's move on to next question. Next question is, it is given that we have to find number of distinct real roots for this equation, and this determinant is given in interval minus pi by 4 to pi by 4. Okay, let's first solve this determinant. So what we can do here, you just apply this operation. C1 changes to C1 plus C2 plus C3. This determinant will be cos x plus 2 sin x. Again this will be cos x plus 2 sin x and cos x plus 2 sin x. So we get first column of this determinant. Remaining two will be as it is. Okay. So if I take common out of it, it will be cos x plus 2 sin x, and we are left with this will be 1, 1, 1, and remaining two column will be sin x, cos x, sin x, and then sin x, cos x. Okay. Now you can change R1 changes to R1 minus R2 or R1 minus R3. R2 changes to R2 minus R3. Upon solving, we will get this determinant. This cos x plus 2 sin x is common, and this sin x minus cos x whole square will be common, and we are left with this much only. 0 0 1 1 minus 1 sin x and 0 1 cos x, and this is equal to 0 given. Okay, so that means from this we can say tan x is equal to minus 1 by 2, and from this we will get tan x is equal to 1, and this will be a constant, so you need not to bother about it. So we are getting two solutions out of this. The correct answer to this question is option C. That means we are getting two distinct real solutions. Okay, let's move on to next question. Okay, now in this question it is given that function fx is 1 by x minus k minus 1 upon e to the power 2x minus 1, and this is continuous at x equal to 0. So you have to find ordered pair k and f of 0. Okay, so we can say if this function is continuous, then f of 0, this will be equal to limit x approaches to 0 of fx, and fx is 1 by x minus k minus 1 over e to the power 2x minus 1. Okay, now if you take LCM of this, it will be limit x approaches to 0 x into e to the power 2x minus 1, and numerator will be e to the power 2x minus 1, minus 1 will be here, minus k minus 1 into x. Okay, we know that expansion of e to the power x is 1 plus x square plus x cube by 3 factorial and so on. Okay, so expansion of e to the power 2x will be 1 plus 2x plus 2x square by 2 factorial, 2x cube by 3 factorial and so on. Okay, so we have to use that expansion here. Let's try that. So it will be like limit x approaches to 0 and 1 plus 2x plus 2x square by 2 factorial, that means 4x square by 2 factorial plus 8x cube by 3 factorial and so on. Okay, minus 1 is there, minus this is the expansion, minus k minus 1x is there, divided by, again in denominator, this is x into 1 plus 2x plus 4x square by 2 factorial plus 8x cube by 3 factorial and so on. Okay, minus 1 is there. So we can say this minus 1 will cancel out with this. Okay, and again this minus will cancel out with this, and if you take x common out of numerator, again it will be cancelled. So we are left with limit x approaches to 0 to plus 4x by 2 factorial plus 8x square by 3 factorial plus so on. In the end it will be minus k minus 1 divided by, again if you take x common out of it, we will be left with 2 plus 4x by 2 factorial plus 8x square by 3 factorial plus so on. Okay, now if this limit is to be defined, that means these two values, sum of these two values should be equal to 0. That means we can say that 2 minus k minus 1, this should be equal to 0. That means k is equal to 3. So we get value of k equal to 3 here, and we can substitute this value of k in this numerator. So we will get this will cancel out. Okay, and now we take x common out of numerator and denominator, they will cancel out and we are left with 1 only. So we can say that f of 0 is 1 and value of k is 3. So correct answer to this question is B. Option B is correct answer to this question. Okay, I hope this is clear. Let's move on to next question. Next question is we need to find value of the given expression where y is given as okay, x plus root x square minus 1 whole to the power 15 plus x minus root x square minus 1 whole to the power 15. Okay, so how to differentiate it? Let's try this. First of all, dy by dx will be 15 into x plus root x square minus 1 into it will be 1 plus x into root x square minus using chain rule. Okay, plus 15 into x minus root x square minus 1 to the power 14. This is power 14 here also, into 1 minus 1 by x by root x square minus 1. Okay. Now if you take LCM of this bracket and this bracket, this power will again become 50. That means we can say that dy by dx is equal to 15 times of this whole term will become y divided by root of x square minus 1 whole square. Okay, no, not whole square, this is sum only, not whole square. Okay, now you just cross multiply root x square minus 1 into dy by dx. This is equal to 15y. Again differentiate it. You can apply product rule on left hand side. It will be x upon root x square minus 1 dy by dx plus root x square minus 1 into d2y by dx square. This is equal to 15 into dy by dx. Okay, that means x into dy by dx plus x square minus 1 into d2y by dx square. This will be equal to 15 root x square minus 1 minus 15 by root x square minus 1 into y. So 225 y. This should be your final answer. Option D is correct answer to this question. Okay. Okay. So next question is f is a function from R to R, and it is given that mod of fx is less than or equal to x square. This is an important question. Okay. We have to check out of these four conditions which is correct. So it is given that mod of fx is less than or equal to x square, and we know that f dash 0, this is equal to limit h approaches to 0 fh minus f0 over h minus 0. That means we can say this will be equal to f of h upon h. Okay, and we also know that mod of fh upon h, this will be less than or equal to mod of h. Okay, according to given condition. So we can say that mod of, no, not mod of, fh by h, this will lie between minus mod of h to mod of h. Okay, this is clear here, na? So here we can replace by mod. So we can say now this is 0, this is 0. So by using squeeze principle, we can say that limit h approaches to 0 of fh by h, this is also 0. Okay, that means f dash 0 is equal to 0. So we can say that this fx function is differentiable at x equal to 0, and if function is differentiable, it is continuous also. So we can say that mod of fx less than equal to x square. Okay, if fx is satisfying this condition, then fx is continuous as well as differentiable at x equal to 0. So your correct answer is B option. Okay, so B is correct answer to this question. So that's it. I hope you enjoyed the session. Thank you so much.